Okay, my presentation is just going to be going through, it comes on, here we go. Going through some Maya and Nuke integration, as we said. And let me just load up my script so we can see where I'm going. Okay, so this is the example I'm going to go with. What we have here, if I in fact load up the rendered final, here we go. So this is a projection setup which is using Nuke to do probably 90% of this, and the rest of it is done in Maya. So the geometry that we're projecting onto is all built inside of Maya, but pretty much everything else is made inside of Nuke. So I want to go through and show you the techniques that I've used to do this. So if we just come out of here, and we start by going back to the beginning, so you can see what I started with. So this is the steel frame that I first begin with, and obviously we have no movement being a steel. So first thing we need to do is we need to build the geometry that we're going to be projecting onto. Now before I can do that, I need to do some cleanup because there's some lens distortion on this image. And there's obviously many ways to do this, but inside of Nuke we have the ability to do cleanup, or rather lens distortion changes on the card itself. And the card is just a 3D sheet that exists in the environment, 3D environment. So if I just bring this up and scroll back, you can see here is our 3D environment inside of Nuke. And this card is just placed here at the center. And we have a camera that's viewing the card. Now on the card itself, we have a number of controls here on the lens distortion. And this basically enables us to adjust how the distortion on that card is taking place. It's not actually warping the card in Z, it's just kind of changing it in the X and Y axis. Okay, so we can use that to take out any lens distortion that we may find. Now, this can be quite useful. Normally if you were on set, you may have the, just move over here, you may have someone photograph for you a distortion grid. So if we just show that. So before any live action was shot, you'd have a distortion grid shot. And so we would just take this into Nuke and apply that onto the card in the 3D scene. And then you would use the lens distortion here to basically remove that distortion, get these lines straight again. And that could then be rendered out, so we can just see that's now straight. So we've gone from distorted to straight. And those figures here that we see can then be transferred across to other material that would have been shot with the same camera, the same lens. So although this isn't the actual image using this distortion, if I plug this in to here, you could see that this image now that we looked at the beginning has now been undistorted based on the information that we got from this grid. Okay. Now it's also been alluded to earlier, but I'll just show you if we just move over to here. The fact that the card also has on it the ability to adjust the focal length and the horizontal aperture. And this can be really important if you're doing pan and tile setup. So this is just a photo that I took out from my house. And what I was able to do is I obviously knew what the focal length was when I took this, and I was also able to find out the horizontal aperture from the camera information. So that's then been placed onto a card in 3D space, and that focal length and horizontal aperture has been added to the information here on the card. When I then pass that through the scanline renderer, what we see here is an exact replica of the original photo. So if I put my viewer on to here, this is the original, And then if I click, this is what's coming out of the scanline renderer. So you can see for pan and tile setup, you can get a one-to-one match. Even if we go right in close here, you can see the pixels are exactly the same. So we can just guarantee that doing any form of pan and tile, you're going to get a good setup. So I undistorted my image, and I fed it into Maya. So let's just quickly load up Maya so you can see what I did there. Give it a second to run up. Okay, and I load my file. So this is the final image, this is the final model that I exported out of Maya. And what I basically did was I made a cube that was originally what I built this building from. And I lined up my camera based on the background plate to get this in the right position. And from that, I then built all the geometry. And I don't want to go too far into Maya, because we're obviously interested in Nuke. But all this geometry was then based on the camera position and then building really from eye where everything was in the scene. Okay, so that was then all exported as a Autodesk FBX file. And these locators that you're seeing here, these are just nulls. And I put them in here because I wanted to make sure that I knew exactly where this building was on all the corners in case Nuke had any problem reading or positioning the information from the FBX. As it happened, it came in absolutely perfectly first time, so I didn't need those at all. So if we just come back into Nuke and we move down into this section, what we're doing here is we are splitting our geometry into 3 sections. Okay, so we have what I'm calling my hero building, which if we just go to here, hopefully it should come up. Just not. Typical. So let's draw up. Here we go. So back to 3D. There it is. Okay. So we have our hero building here, the green one, and then I've done my secondary buildings here, you can see, and the ground. And I've done these in 2 groups. And the reason why I've done that is when the camera moves, obviously with any form of parallax taking place in the scene, you're going to reveal somewhat behind the foreground objects. So when we move the camera, anything behind this building is going to kind of peep out. And so in order not to have the building kind of reveal itself, I needed 2 setups, one for the foreground building and one for the background. And that's what I've done. So if we look here on our first one, I have this shot where I've basically, in Photoshop, gone in and cut away and cloned the background over the front of this building. And then I also, over here, have an unpainted version. So you can just see the change I've made there, just done pretty straightforwardly. What I've also done is, on this one, I've decided that these people down here I didn't want in the scene, so I've just used the Nuke paint node, just to paint those out. And we're taking the camera information from Maya, and we're taking the building and the ground, and we're basically projecting the image from here. So this image, we're projecting onto the geometry, just like we did inside of Maya. So when we look at that, this is what we get. So this is the projected image onto the secondary buildings and the ground. When we come over here and look at this side, you can see this is the projection onto just the main hero building. Okay, now a couple of things about what's happening here. When we do our anything in the 3D inside of Nuke, everything comes out via the scanline renderer. And the scanline renderer doesn't just produce an RGB and alpha image. So you can see we have the matte here. it has many additional kind of outputs that can be really useful to us. For instance, we have the ability to output the Z depth information, and this enables us to do things like fake depth of field or distance queuing in some way. We also have the ability to output motion vectors, which enable us to simulate things like motion blur. And then we have other output vectors, including surface, point, and normal point passes, which I believe Roy will be looking at later. So I've got a very simple scene here, just moving away from our main example, just so you can see. We have, I just load this in, you can see, very basic, just a straightforward animation that was again made in Maya and then imported into Nuke. So it's just a bouncing ball, all the animation comes in, everything's fine. If you're interested in the texturing, Nuke has the ability to texture objects, and there's various types of texturing inside of Nuke. For these two objects, I'm using just a straightforward Phong node and just applying a color to the main ball and the hoop. And you've got many different types of texturing. I'm also lighting the whole thing with a point light. That's where we're getting this specular highlight from. So you can do all this kind of thing. What we're doing here, though, is we are saying that we want to output the Z buffer information from this scene. And then I'm taking that. In fact, I can show you what that looks like. So there is the Z depth. And I'm just grading the Z depth down a bit. So we're making the things in the foreground brighter and the hoop in the background darker. And just go back to the RGB. And then I'm using this Z blur node, which is basically going to use that data, and it's going to blur the image based on that color information that we just looked at. So as the ball moves towards the hoop, you can see we then get that ball as it goes into that area becoming defocused as well. Okay, so there's lots of different things we can do with the scanline renderer. So if we just move across, so we have two outputs. We have our hero building, and we have our secondary and ground here. And we're then just merging those together here, which gives us our final starting place for our scene. And this is merging RGB, the alpha channel, and the Z depth information. Now, one of the things I wanted to do was just deal with these edges where we're getting some pixelation. Now, I've put this on deliberately so we can I can just show you this technique. I'm sure you're aware of it. The scanline renderer has the ability to have anti-aliasing added. I've just got it on quite a low setting here. If you go into the multi-samples, you can really crank this right up. And obviously, the higher you put it, the slower your render takes, but we would be used to that in 3D. But what I'm going to do is I'm going to just blur these edges to integrate this foreground building with the background. And to do that, I'm simply just making a couple of masks based on the alpha information. So if I just go to the alpha channel here, you can see we have our building here, and then we're doing an invert of that, which is obviously giving us a black building on white. And then I'm merging these together with a XOR merge. You can see here our merge has lots of different settings, and I'm just using an XOR. And that just gives us this very small pixel line. What I'm now doing is just using that line to blur everything in the image other than everything in the image based on where this line is. So if we come to our blur node here, and I come back out of the alpha channel into the RGB channel, and we zoom in, and I take this mask off, you can see at the moment everything on our image is being blurred. Okay? But if I plug this output from here into our merge, into our mask rather, you can see it now only blurs where those edges are. And this ability to add a mask into a node is one way of getting mask information into any node within Nuke. And believe if you're using Shake, it's the normal way of getting things in and out of nodes, but there are other ways you may know inside of Nuke to do this. Okay, so from here, I'm just adding the motion vector information from the scanline renderer. It's basically combining the foreground and the background motion vectors in here, and we will be utilizing that in a minute. Okay, what I'm now doing is I've decided in my shot that I want to add some grime and dirt to this side of the building here. So a couple of things I could do. I could obviously project the image on, and this is the image I'm using. But what I've decided to do instead of doing that is, obviously when you project something, it's a light-based operation. You're just shining an image onto the building. Now I wanted to have a little bit more control. So what I'm using is the Nuke's UV projection. Now, UV is obviously utilized a lot in 3D, and it's the ability to adjust how the geometry actually deals with textures being applied to it. So let me just slide over here and give you an example of that. So if I just show you our scene here, and just go to our render view. Okay, so this is what happens if we simply take my hoop from Maya that was produced without any UV data, and we just apply this Nuke logo to it. We basically get this kind of a mess. Now what we can do is we can use the UV projection system to add UV data onto the geometry. And there's lots of different ways that you can do this, just like you would in 3D. You have the ability to do it as a perspective or a planar. You can do spherical or cylindrical UV projection. So if I add the cylindrical one, so we just change this to cylindrical, you can see as I move around this axis, you can see that we're basically changing how that UV information is applied. We can even go as far as to rotate that, and you can now see really clearly what's going on. We could also say we want to project the UV just as a planar surface. So if I come into my camera here and I move my camera, this isn't projecting, although I'm using a camera. This is mapping the UV data. And in the UV here, I've got the ability to do things like scale it, so I can adjust the size of this just like you would in a 3D application. Okay, so two totally different ways of dealing with textures, either projecting a texture on using light-based camera projection, or do it geometry-based using this UV technique. So that's what I've used over here. So I've taken my grime here, and I've brought the building back in, and I've used this camera over here to the side, and I'm basically adding planar UV coordinates to the side of the building. I just happen to be using a camera. I could easily use an axis node, and as I move the position of that camera, that's obviously changing what's happening with our UV data. That is then all being rendered out from our scan line, which is getting us this image. And I'm just using a Bezier here because I actually had a bit of noise earlier on over here where the UV texture was kind of breaking through to the other side of the building. So I used just a roto just to get rid of that. And the other thing that I decided I wanted to do was where this texture is, I didn't want it to appear on the windows of the building. So I've used a simple Luma key here. If we just go to the alpha channel. So this is a Luma key, really rough, pulled to the building. And I'm adding my grime to that, and therefore just removing where the windows are, so we don't get any noise or dirt on the windows. And then adding that here onto the building. So you can see that there. Okay, so far, if I just run this up in Frame Cycler, which is Nuke's kind of preview system, and run that, you can see that the grime sits perfectly on the building because it's actually projected or textured using the UV data straight onto the geometry. This is where we've got to so far.